So in this video, I'm going to follow on from the last video where we found the Laurent series centered around a puncture disk of z equals 3. This time we're going to do z equals 5 and we're going to compare the two Laurent series and see how they look, and maybe it makes no change. Let's see what happens. So first of all, what I'm going to do is I'm just going to define f of z as this fractional polynomial here. So that's 1 over z minus 3 z minus 5. And a couple of ways we can do this, but the way I like to do this is do a change of variable with w. So I let w equal, well in this case I'm going to go around z equals 5, so I'm going to let w equal z minus 5. And then what I'm going to do is substitute that into here and produce an f of w. So I've got f of w now equals 1 over, well, z minus 3 will be w plus 2. So I've got w plus 2, and then z minus 5, that's my w. So I've just got w. Now I'm going to do partial fraction decomposition of this. So I'll now have two constants to find with this w plus 2 and w. Now cover up method, cover up this to find a, I need to plug in w equals minus 2. So if w equals minus 2, that disappears, then plug in minus 2 here, I've got a is minus a half. So a equals minus 1/2. And then for this one, plug in w equals 0 to find b. This will cover up and I'll get b equals 1/2. So b equals 1/2. So now I can rewrite my f of w. So f of w is now minus 1 over 2 w plus 2. And here b is 1/2. So I've got plus 1 over 2w. Okay, now this is already sorted for me. That's 1/2 of 1 over w. And then here I can make a power series out of this, because as we want a Laurent series, I'm going to need to make a power series somewhere with one of these two terms. This is the one for me. So if I factor out minus 1/2, let's deal with that. So I've got minus 1/2 and then 1 over w plus 2. So times that, 1 over w plus 2. Okay, so now what I can do, I can rewrite that the other way round and do it as the 2 plus w. And then I've got something that could look like a power series that I know. Now I know 1 over 1 plus x, that's my alternating series. So that is equivalent, so this becomes this, whatever my x is. So I just leave a little gap. So I put my x to the n, and as it's alternating, I need to put in my alternating part for a series, minus 1 to the n. So here that runs from n equals 0 to infinity. Okay, now here I've got 2 plus w. Now I want to factor out another half. So then let's factor out minus 1 over 2. Put that in brackets as it's multiplied. Factor out a half. And then that's going to leave me 1 plus w over 2. Now we can see here what's happening. Just put that in a brackets just to be careful. So w over 2 is here. So now my x here is w over 2. So let's just write that into there. So I've got 1 over 1 plus w over 2. That becomes n equals 0 to infinity minus 1 to the n. And then my x is just that. So I've got w over 2 to the n. So now I can rewrite this. That's just dealing with this particular part of the term. So this now becomes, so minus 1 over 4, I can take that out. So minus 1 over 4. And then this just becomes this. That is equivalent to that in terms of a series. Hence Laurent series, that's what we want. So now let's put my series there, n equals 0 to infinity, and then minus 1 to the n, and w over 2 to the n. Okay, now remember we're finding the series in terms of z, so what I want now is just to transfer this in terms of z. So what is w? That is z minus 5. So I can substitute that into here. So what I'm going to do is now clear off the board and write it under here, and let's continue with the power series. Okay, so now here we are in terms of f of w. Now I did my substitution, w equals z minus 5, so I need to bring it back in terms of z. That was my original question. So now f of z, that's going to be, as w is z minus 5, 1 over 2 z minus 5, and then minus 1/4 times n equals 0 to infinity. Now here I've got minus 1 to the n, that's fine. There's no transfer of variables to there. And then w, again I put a z minus 5. So I've got z minus 5 over 2 all to the power of n. So now let's build this up using from n equals 0 to, again, up to 2 like I did in my last video. So when n is 0, first term here, so now let's write f of z. I've got 1 over 2, let's write that 2 so it doesn't look like a z. So 2z minus 5. So that's fine for n equals 0, and that would be included for all, so that just stays on its own as a first term. Then when n is 0, I've got minus 1 to the 0, which is just 1. Z minus 5 over 2 to 0, which is also 1. So this just becomes 1. So I've got minus 1/4. So that takes care of that. And now let's concentrate on these terms when n is 1 and when n is 2. So when n is 1, I've still got this minus 1/4. So I've got minus 1/4 times minus 1 to the power of 1, that's going to give me minus 1. So times minus 1. And then z minus 5 to the power of 1 over 2 to the power of 1, which is over 2. So then that's just going to be multiplied by z minus 5 over 2. So that's all of one term. Now, when n is to the power of 2, still got minus 1/4. So I've got minus 1/4 times minus 1 squared, which is just 1. So I'm going to put the 1 in there, just so as we can see that working in our summation. And I've got z minus 5 squared, and then 2 over 2 to the power of 2 in the denominator, give me 4. Okay, now let's just tidy this up a little bit. So then that becomes, I'm going to put my constant term first. Then I'm going to add this term with z minus 5 in my denominator. So add 1 over 2 z minus 5. So that's that and that taken care of. Let's take care of this z minus 5 to the power of 1 term. So z minus 5 to the power of 1, I've got minus 1/4 times minus 1, so that's plus 1/4. And that's multiplied by z minus 5 over 2. So that's going to give me z minus 5 over 8. Okay, now this one, I've got minus 1/4 times 1, still stays as minus 1/4, but I've got a 4 here, so I've got minus 1 over 16. So let's just put 16 there. And then minus 1 times this, just give me z minus 5 squared. And then from z minus 5 cubed, I'm not going to be included in my terms, so I'm going to put o z cubed as just to end my series. And that be my Laurent series at a punctured disk around z equals 5. Now, where is this series valid? Well, at z minus 3, I'm going to have another singularity. So my range here for the modulus of z minus 5 will be 2. So basically what I've got is from 0, z minus 5 and less than 2. So it's going to be an annulus of z minus 5 with a radius of 2. Okay, and that completes that.